The 1-point T-99 test is the primary test used to determine the maximum density of cohesive soils, which we know are those soils which have a loss by wash greater than 15%. This is a Michigan adaptation of the AASHTO T-99 Method C modified test. The modification to the AASHTO test procedure is described in the Michigan Test Method MTM 404. The 1-point T-99 test uses the following equipment: a Proctor mold with a detachable collar and base plate, the pounding block, a spoon, a 1/4-inch screen, a sample pan, a 1-point T-99 chart, a strike-off bar, water jug, and a 5.5-pound rammer with a 12-inch drop. The volume and weight of the mold are written on the outside of the mold. On Form 0582B, you will write down the volume of the empty mold in column C. In this case, the volume is 0.0360. In column E, you'll write the weight of the empty mold. In this case, 2,618 grams. The material used for determining the maximum density is taken from beneath the in-place test. Because cohesive soil is normally blocky, it needs to be run through the 1/4-inch screen before the test is run. Any stones left on the screen need to be inspected for size. Stones larger than 1 inch should be discarded and replaced by smaller stones of an equivalent weight. Incorporate the stones less than 1 inch back into the sample and mix it up. Before you start your test, there is something you must remember that is very important. As only one mold will be pounded, it is important that the soil has a moisture content between optimum and 4% below optimum. Optimum moisture is the moisture content at which you can obtain the highest maximum density with a given amount of effort. As you have no idea what the real optimum moisture is before you run the test, there is a simple test that the inspector can use to see if the soil is within the approximate required moisture range. Take a handful of material and form a hand cast by squeezing it in your fist. The cast should hold firmly together, but still be able to be broken with a little effort. If the cast crumbles too easily, water should be added to the sample. If the cast molds very easily, like modeling clay, it is too wet and needs to be dried. Whether drying or adding moisture, be certain to screen the soil after to be certain the moisture is well distributed throughout the sample. Make certain the pounding block is on solid ground. The mold should be tightly screwed to the base plate and the removable collar tightened to the mold. The mold will be filled in 3 equal lifts, with each lift being compacted by 25 blows of the rammer. Put enough material into the mold so it will be 1/3 full after compactive effort. A little field experience will show you approximately how much to use on each lift. Holding the rammer perpendicular to the mold and bringing the sliding weight to the top, allow the weight to freely drop. Repeat this 25 times. Be certain only 25 blows are used. Make sure the 5.5-pound weight falls the full 12 inches. While compacting the soil, the rammer should be moved around the soil surface in the mold to obtain uniform compactive effort on the layer of soil. It is important that the rammer be held straight and the weight dropped freely. Since this is a standard compactive effort, any increase or decrease in the effort may affect the test's accuracy. A second layer of soil is added, filling another 1/3 of the mold's volume after compaction. This is also compacted by 25 evenly distributed blows. The third and final layer is then added, including enough soil to extend above the mold a 1/4 inch to a 1/2 inch after 25 compactive blows. This graphic illustration gives an idea of the appearance of layers, compacted by 25 blows per layer for a total of 75 blows. When removing the collar, loosen the bolt and twist the collar before lifting straight up. This will prevent you from accidentally pulling off the last layer. After removing the collar, you want the soil to extend out of the mold a 1/4 inch to 1/2 inch. If you are too low when finished, you must start over. If the material is above the 1/2 inch, you may use the mold for this test if you are pressed for time, but you must do another at your next in-place test location The soil is then struck off with the strike-off bar. Don't try to cut the soil off with only one cut. Shave around the edges and work towards the middle. To keep from bending down, you may move the mold to the tailgate of your truck when using the strike-off bar. When you think you're close, use the sharp edge of the strike-off bar and make an X on the top of the mold. If you can see lines, keep working at it. If you encounter a stone that is sticking out slightly, use the blunt end of the strike-off bar and pound the stone into the soil the rest of the way. If you encounter a stone that is sticking out more than halfway, remove the stone and replace the void with the fine soil shavings that you just shaved off. This is showing what the mold should look like after you're done. It should be relatively free of voids, smooth, and even. Remove the mold from the base plate and weigh the sample on the scale. Make sure your scale is level and the mold is centered, and record to the nearest gram on form 0582B. Complete computations through column H, compacted soil wet. First we subtract the weight of the mold in column E from the weight of wet soil plus the mold in column D. The result is recorded in column F, wet soil. In this example, 4,820 grams, wet soil plus mold, minus 2,618 grams, the mold, equals 2,202 grams, wet soil. Next we convert the wet soil weight in grams, column F, to pounds by dividing by 453.59. Formula located under Note on the lower right side of form 0582B, and record in column G, wet soil in pounds, to the nearest hundredth. In this example, 2,202 wet soil in grams divided by 453.59 equals 4.85 the wet soil in pounds. Then take the wet soil in pounds, column G, and divide by the volume of the mold, column C, to get the compacted soil wet, PCF, in column H. Record to the nearest tenth. In this example, 4.85, the wet soil in pounds, divided by 0.0360, the volume of the mold, equals 134.7. If the material has been manipulated, the speedy is required to figure out the moisture percentage. When going through the speedy test, gently roll in the steel balls. Loosen the mold to remove the sample. After removing the sample from the mold, the sample can be broken into 3 equal layers. Use the center portion to get a sample from. Cut the center portion into a pie shape and run enough material through the screen to obtain a moisture sample. As this is a cohesive soil, or a soil with a loss by wash of greater than 15%, we will use a half sample. After tightening the top screw, rotate and read until the needle stops moving. By definition, the needle stops moving when you have 3 consecutive readings that are the same. Take the dial reading. In this case, it is 5, and as this is a half sample, double it to get 10.0. Find the 10.0 on the conversion chart. Follow it across to find the oven dry moisture content percent value, which in this case is 11.0. Record the oven dry moisture content of 11.0 in column B, moisture percent of the form 0582B. When a speedy is used to obtain a moisture percent, you need to indicate with an S next to the moisture percent value and circle the S. Or you can also write out speedy off to the side. This indicates that the material was too wet or too dry from the nuclear gauge reading, and you had to manipulate the soil by drying or by adding water before pounding your mold. Now you have 2 required values, moisture percent and compacted soil wet, to take to the 1-point T-99 chart. This is the 1-point T-99 chart used to obtain maximum density and optimum moisture for cohesive soils. Compacted soil wet values are located along the vertical axis, and moisture content values are located along the horizontal axis. Maximum density values are along the curve. First, locate your moisture content value, 11.0, along the horizontal axis, and compacted soil wet value, 134.7, along the vertical axis. Proceed upward with the moisture content value, and proceed to the right with the compacted soil wet value. Where those two intersect, make a point. Next, from this point, project a line diagonally, roughly parallel to the guidelines, until you meet the maximum density line. This point will give you the maximum unit weight, or maximum density, for this test. In this example, we come up with a value of 122.8. Read the value to the nearest tenth. Record the value of 122.8 in column I of Form 0582B. This is your maximum density value for the particular material you just tested. Finally, we proceed vertically downward from our point at 122.8 to the intersection with the moisture content axis. This value gives us our optimum moisture content, which is 11.7 in this example. Record the value of 11.7 in column J of Form 0582B. This is your optimum moisture value of the particular material you just tested. Now that we have our optimum moisture percent, we can compare it to our percent moisture. This percent moisture has to be between optimum and 4% below. In this example, our optimum moisture is 11.7%, so our range for percent moisture is 11.7 to 7.7. Our percent moisture is at 11.0, so this maximum density is valid. Because this test is valid, we may now carry the max density of 122.8 upward to column 10. This is the number that will be entered into the Troxler 3440, the Proctor value, under the Proctor-Marshall button. When that is done, the gauge will compare the maximum density with the dry density to give a percent of compaction. In this case, it was computed as 93.7. This ends the section on the 1-point T-99 test. You may turn to the section of the density testing and inspection manual entitled The 1-point T-99 Test. Review the material if you desire.